Hello, everyone, and welcome to my talk. Today, I'm here to present to you a topic on exploring stateful microservices built with open liberty in Kubernetes. My name is Mary Grygleski, and I'm a senior developer advocate at IBM. You may wonder, who is Mary Grygleski? I'm a developer advocate at IBM. I first started talking about reactive systems. If you have seen me before, I was doing a lot more reactive systems for the past a year and a half or so. Then recently, I transferred team to the WebSphere team and Liberty and all the open source Java tech stack within IBM. This is where I am now. So my area as such also involves cloud native, cloud, DevOps, enterprise distributed systems. And my projects now include Open Liberty, Microprofile, Jakarta EE, and more. I'm essentially a developer relations software engineer. And I myself, I have 25 years of experience being an engineer in development work and its delivery work as well. And so I kind of understand, not just like coming out to talk, but I myself was an engineer dealing with delivery of software in the past. And outside of my work, I'm also a very active community builder. I'm currently the president of the Chicago Java Users Group. I'm also the co-organizers for several IBM-sponsored meetups in the Chicago area, and that's where I'm located. And I'm also an active church volunteer. So today's topic is about stateful microservices. But before we get into there, I figure let me start, have a bit of a background, make sure we set the context correctly. But before we get into some serious stuff, let's kind of talk about what stateful versus stateless means. Actually, as I was doing research on this topic, and by the way, it's a new topic for me too, so bear with me. And we're all at the tip of the iceberg because there are like tons of information that have yet to be mined from this topic area. So exciting too. And also too, for me, coming from a reactive background, I see a lot of overlapping concepts that are like, that cut across, it's not like black and white that's reactive and that's stateful. The fact is that reactive too, also, we have to handle the state of any application. And as such, now I'm perhaps not talking so much about the reactive side, but as you can see, some of the concepts, the goals in being stateful, your microservices really touches upon reactive. But anyway, let's have some fun stuff first. So as you can see, I now have a picture of Nemo, his dad, Marlin, and the forgetful fish, Dory. So if you know the story, then you may be able to guess why I am borrowing this idea. I actually have to say too is that it's somewhere where I read about somebody talking about stateful microservices. They brought up Nemo and I kind of gave me ideas. So just so you know, it's not like my own original idea, but I certainly got into it and because I know the story. So I just thought definitely it's a great analogy to be used at a conference, right? Less boring and let's talk about fish. So let's use them to kind of illustrate. So as you know, and for some of you who are not familiar with the story, let me give kind of like a 2-minute run through of it. So Nemo is this small baby fish, and Nemo actually lost his mom, so just living with his dad, Marlin, so the bigger clownfish, the orange clownfish. So both of them living together and happy. Then all of a sudden one day, Nemo got into trouble, and he got caught, captured by some, I wouldn't say bad people, but just captured. And obviously, as you can imagine, the dad was like frantic, trying to look for Nemo. So during the course of it, he was swimming around and then he bumped into this bluefish, Dory. She actually is a very forgetful fish. She doesn't remember anything. Now, as the story goes, and even if you are new to the story, you can imagine, right? Have you ever dealt with people who are forgetful? And I really don't mean to be like, make fun of such situation. There are people too with medical conditions that do not have, memory too. But as you can see, in a cartoon kind of manner too, we just kind of, laugh about things like that in a funny story like this. You can see too, Dory is a lot more agile. Like she can do whatever she wants at any moment without concern for what has happened before, right? Or something like that. So you can kind of see, I mean, it's basically the idea of if you don't need to remember things, you actually can go ahead and do things. You're less concerned, you're less burdened, less carrying of the baggage. Whereas like Marlon, is a more normal, kind of like a normal person, right? We remember things. So he naturally remembers things. And as you can see, both of them embark on their journey to look for Nemo was full of fun, really hilarious kind of moments. One of the things maybe I should quote was that when there was a group of jellyfish, and Dory thought they were really cute. They are pink in color, kind of round, kind of ball floating. So Dory went and was like trying to, so to speak, jump on these jellyfish because she had no idea that jellyfish would sting. Whereas Marlon is like, hey, wait a minute, what are you doing? Are you crazy? You're going to be stinged like that. So that's kind of an example of, how hilarious it can be. But it really illustrates too that there's the stateful and stateless. Some of these concepts, you can actually use that as like an analogous to what we're trying to talk about today on this topic is that, being stateless, it's kind of a lot simpler, right? In a computing sense too. Computing life used to be simpler too in the beginning of time of computers. There were no such thing as state, right? That we need to worry about other than the fact that the state would exist during the, let's say a computation, doing a math 1 + 2, some kind of mathematical formula. It only needs to exist, the memory, for that period of time. Once you get the result, it essentially, the memory gets thrown away. You don't keep the data around. And that's the idea. But the thing is too, well, okay, let's kind of like go in a bit now. So stateless computing. Now, moving back into the serious matter about computing, what is stateless computing? So essentially, it is a communication protocol that does not retain any session information. So state of the data, right? Anytime we deal with protocol, we deal with like multiple parties or at least two. So your receiver receives the data. You don't need to remember what the state was before you receive it. So that's the idea. So the data itself doesn't get recorded between transactions. As a result, you can see that the architecture of your system, design, implementation too, everything is a lot simpler. Scaling the system, no problem, right? If you have processor processing some systems and here you are, there are more demands now, more requests coming in. Then what do? You scale it up, you add more processor to it, more to handle all the demands, no big deal. Just add it, right? So it kind of relates to what we are doing today too, even with cloud computing. We need more, servers in serverless computing, right? That's the thing. The infrastructure, it keeps spinning. And that's why the idea of like cloud native in a strictest sense too is really serverless. It helps to scale the system a lot easier. And of course too, if there's system crash, then the recoverables, it's very recoverable. It's very easy because there's no need for you to when you restart, there's no need for you to have to remember, well, what was the state before that I need to kind of read memory and kind of restart. So everything is a lot more agile, as you can see. Now, realistically, we actually live in a stateful world, and we really cannot survive if we are living statelessly, right? But it doesn't mean that we have to have all applications be stateful. In some circumstances, stateless is fine, functional style of programming, serverless, that's okay. But the bulk of our applications, we do require state, right? When, let's say you log on, to your web page, right? Your web application, you log on, you want to retain the credentials when you are still within the session. You don't want to have, every request. You don't need to re-authenticate yourself every time you just make a request within the same session. So that kind of a statefulness is what we're looking at. Stateful computing. This really is a communication protocol that would retain all session information. So it gets recorded at every step along the way, right? All transactions, everything. Supposedly, right, theoretically, nothing should be, lost. And in some ways, too, you guarantee, right, that you can kind of look back at the system and dig up all the history information. Now, as a result, too, because you do need to keep all of these historical data, the logging and everything, then naturally, too, you can see the architecture, the implementation, implementation, the design of the system is more complex, is more convoluted, and you have to handle many situations. And what about, if you need to spin off more components when, you get higher number of requests coming into your system, then you need to scale your system, will be a lot harder, because what do you do if you kind of spin off another node? Then you want to make sure that node is synced up to what the other running nodes already have. So as you can see, right, the overall performance to scaling it, everything's just more work, more cumbersome. Recoverability, same thing. If there's a system failure, you need to restart. Well, that's kind of a pain in the neck, because then now you need to make sure when you recover the system, you need to read from the history to see how you can reconstruct the state that system was in, prior to the crash and all that. So as you can see, it's not as simple, right, doing stateful. How about then, let's take a look. How was statefulness being handled in the cloudless days? So here I am using a blue sky, and you can see, all blue sky is just a jet plane, flyby, and in the blue sky, cloudless days before cloud. So it was all like client server systems. Now we rely a lot to back then, let's say not going back to all the way to the, beginning of history in computing, but let's say even like between the time or after like the 90s, right, in the 2000s when Java came out, let's talk about that time. So a lot of statefulness too was being done, using database style transaction. So we rely a lot too on the database to essentially keep data to be persistent on the server side. So all of these transactions are also being handled by the database. We leverage a lot on the database itself. Now, as far as Java goes, essentially too, if you have worked with enterprise Java beans, the earlier specification of enterprise Java, the EE edition, right, Java EE or J2EE, what it used to be, and now it's called Jakarta EE, right, just recently changed name about a year and a half ago. So Java used to be enterprise Java beans, EJB, stateful EJB. If you work with that, you're aware of stateless EJB. It's a lot simpler to do. Whereas like with stateful is actually a lot more work. And then there's also the enterprise level stateful. And actually, now I kind of think of it, don't quite remember. I actually work for a company that manufacture app server. So I actually knew the spec quite well because I had to implement a lot of the management function. But anyway, so stateful, it was being handled by stateful EJB. And the thing is too, like, what about servlets, right? So servlets too is essentially rely on HTTP session. So the session is what kind of like keeps track of the session information and kind of communicates with all the web requests that comes in. And then as far as the client side is concerned, then client side would cache like server responses. So say, for example, these are examples, right? All like web applications too will have to, any request you make to the server, you authenticate. So the authentication process, either kind of make use of a cookie-based type of authentication or like doing like token-based authentication. So cookie-based, as you know too, it has concern, even though, right, the cookie itself is small piece of information, essentially is your session ID, right, that you communicate back to the server. So that's how you can see too, this external mechanism is needed in order to be able to communicate back to the server that, hey, this request coming in, I have this cookie, then server can look up and then, know that, okay, well, this is which request it is kind of coming from, who is the client, that you can kind of reuse the same session information. And then, of course, then there's also token-based authentication, and that's JWT is more popular, right? The JSON web token. And that too, for JSON too, it's a bit, actually JSON is a bit more efficient than cookie. As you know too, for cookie, right? You basically, give the server your session ID, and then the server would have to then look up the information, and then basically you have to then, have kind of multi-steps. You need to look up the information, then you process the request. However, with a token-based like JWT, then the JWT is allowed to keep more information, right? You can actually encapsulate also the session information in that token. So then it's kind of more like one call to the server. It already has the permission and it looks up and all those things. But anyway, without going into all the detail, but those are kind of the mechanism that was being used, Actually, it's not too much different than what we have to deal with today, but it's just that back then was client server system. So now let's then move into the stateful microservices in cloud native environments. And that's what we're interested to talk about these days. We live in kind of cloud native age, and maybe not everybody has started doing cloud native, but I would imagine very soon we will be, more and more, or I should say more and more applications will move into the cloud native environment. And of course too, then there's stateful, or first of all, microservices. So they are like bite-sized chunk, right, of components in the system that actually kind of is a big enhancement over the old style of doing things in a monolith, right? So now then we pull into this concern of stateful. Let's take a look. You may know too, well, this is kind of a sums up, right? Essentially, you're saying that, well, cloud native, and then we're talking about cloud native is really dealing with stateless containers. Why? Because containers needs to be very agile. You don't want to keep a lot of history information about it, and kind of going back to the Nemo, Marlin, and Dory scenario, right? If you keep too much information, it just slows things down. The goal of cloud native is to have very agile system. So we're wondering, then what to do, right? So let's first kind of understand a bit too of cloud native computing for those of you maybe who are newer to this computing kind of approach. So it's really an overarching approach, right? It's really an extension to cloud computing. It addresses the true needs of an enterprise level distributed business application systems. So these true needs, what are they? Essentially, too, I go back to history. Who started this, coined the term of cloud native? It's really Netflix. Netflix has been really ahead of time in terms of software computing. At the time, well, because of their business too, they need to kind of have, streaming media contents, in high volumes and, high demand. So that's why it pushes them to get to that level of computing early on in the game. And so they coined the term cloud native in the early 2010s. And essentially they wanted to leverage on the cloud to meet their goals for the systems to be highly available, scalable, and performant. So as you can see now, if you're also familiar with reactive systems, and that's where I kind of came from, kind of advocating, I was like, oh, wow, cool. This is like the similarities, right? We're exploring into more and more deeper into the cloud native context for microservices. We want to make sure microservices help systems to be more highly available, right? And this kind of pairs up really well with the reactive concept of being very responsive, right? Very scalable and very resilient. So as you can see, highly available, scalable, and performant. Performant is kind of like the responsive aspect of reactive. So they kind of share these common goals. But anyway, I know I get a bit excited when I kind of get back into talking a bit about reactive. I just believe that sometimes, all these labeling eventually about things is not really black and white. There are so much commonality, things, features, characters between different things that we label them for. But I think ultimately the goal of us doing computing is to provide solutions to solve problems. And that's what it is. So it isn't saying that one thing is better than the other. It really all depends, right? Depends on what you want to do for your system. What do you need? So first of all, anytime you need to provide, look for a solution for your problem, you need to understand your problem first. What are you trying to solve? And then decide on the right tool to use. But anyway, I digress. So let me get back. It's kind of interesting and important. We also bring up cloud native, within this context of stateful microservices. So for cloud native, right, we're kind of having this debate. Well, we're talking about stateful microservices. How is that possible? So cloud native, right? You may also have heard of this 12-factor application. Is a methodology. It essentially helps guide us. It doesn't dictate what you should use, but it's kind of a guiding principle. Another kind of guiding principle, this kind of describe what a cloud native application should do. And it's drafted by developers at Heroku. Again, a set of guidelines, right, for portable and resilient applications that are well suited in the cloud environments. Now, one of the factors, and that's what I'm highlighting too, is the need for self-contained services, which are to be deployed as stateless processes. So microservices architecture, well, so far, right, that's the primary thing is, so far as microservices is the one that can satisfy such a requirement. So here we are. Why am I doing this talk? We're talking, well, what is going on? Stateful microservices? Whereas, in the microservices, when we kind of talk about it today in a cloud native way, it should be stateless, like you're thinking that am I crazy in here, right? But like I said, right, I was trying to point out that it is necessary. We need to address the stateful aspect of any applications. And how do we do it is what we're trying to explore and to see how this can be done, in a microservices cloud native world. 12 vector application. So let's just may as well kind of show it a little bit too. Now, move over here a little bit. So as you can see too, there are 12 vectors, but like I said, you can also read all of it. Some of them you already know, right? We deal with making sure there's a lot of accountability, keeping track of things and the dependencies, configuration, all these things. But I wanted to highlight this in which the number 6, the processes. So execute the app as one or more stateless processes. And then another one is basically, which one? This is number 9, disposability too. It's basically, it says any kind of cloud native apps, it needs to be, able to start up fast and have very graceful shutdown. Fast, everything is fast. So these two kind of cloud native, I think we already touched upon. But now let's kind of ask the next question is, well, how do we preserve state across session, across transaction, and network boundaries? Now, in a cloud-native environment, now we are really dealing with true distributed systems that can, span across many different types of environment, machines, physical. It may not be, be across the ocean too, but it can be, right? It's just basically gives it a lot more flexibility, and you can have data centers that are located all over the world, with an app. You can scale it anywhere. The nodes can be started up anywhere, can be replicated. So how do we preserve state, right? That's the kind of a $1 million question in here. Now, let's talk about then some of the things is kind of like the techniques and mechanisms. It's what we already kind of talk about that we make use of cache, right? We can do caching. It's still very, very valid. And we'll have an example. The demo will show you that and how we do it with OpenLiberty. And then there are also like database style kind of transactions that rely on database. So as you can see, all of these things are really not intrinsic to the microservices itself or maybe the container itself, right? The container, well, what used to be, right? Even like EJB is the EJB Enterprise Java Beanside container and all that. But now it translates to cloud native, which is container. We're talking about infrastructure level, such as like Kubernetes, right? Very popular these days for container orchestration. So anyway, as you can see, all of these two, they are not intrinsic to the containers themselves, but these are like techniques, mechanism that we can utilize. Then there's also cookies, right? We still can make use of cookies too, and sessions and tokens and all these things that we talked about earlier. Again, just now too, I touch upon cloud native infrastructure. So now with cloud native, why don't we then take advantage of the cloud native infrastructure? Infrastructure like Kubernetes, essentially too, there's concepts of stateful sets, right? And that's what it is. Like Kubernetes on the container level, it actually maintains the different set of information. They keep their statefulness in that. And even like say with OpenShift that comes from Red Hat, they also actually have a cloud native kind of concept of stateful cloud native stack too, that essentially is making use of the container level persistence too for you. So again, this is more infrastructural, and that there's also like persistent volume and also cookie affinity. So those are kind of examples of features within Kubernetes that they can handle, help you to persist data across different nodes, things that are replicated. So then takes the burden off of the application itself. Okay, so now get back into a bit more the programming level. We're dealing with programming design pattern. A very prominent pattern these days to think of is the saga pattern, right? So saga is like any kind of saga. So it implies, right, in a story, we like to talk about saga or something. It's kind of like a long running story, right? Something that will last. You're not only like processing things in a spur of the moment, kind of stateless. You're dealing with a long running transaction. So these two, I kind of group them together, but I wanted to also point out too, there's also this thing called long running action. And this one is a form of also saga too. It's like a saga interaction pattern. I probably should be grouping them together, but I can't at the moment find a very clear distinction if they are two separate things because they share a lot of similarities too, but I'm not able to find a documentation that would kind of address both all at once. So I kind of been being careful at least like in terms of the names of these patterns, I kind of split them up into two, but they could easily be kind of combined together. They share a lot of kind of like the similarities, right, in terms of their concepts. So let's get into it. Saga is really like we're helping transactions to span across multiple services. That's the goal. But we don't want to go back to the old ways of database, two-phase commit. Some of you maybe, if you have worked with that before, right? It used to be with transactions, we have 2PC, two-phase commit. So that kind of makes use of like, multiple databases, or say two different databases. You have different transaction coordinator that pass kind of information. Are you done? Are you done? I mean, good. Then you commit, it's a lot of communication going in between. So you can see too, it's probably a lot of messaging. So it's not really suggested. Instead, using a Saga pattern is what, being advocated in a microservices environment. And of course, too, one of the most respected microservices expert, Chris Richardson, who I actually interviewed too on one of our IBM video. If you want to look that up too, we talk a bit too about microservices. It's all of these concepts around it is truly amazing. So back to Saga, right? So there are two ways of doing their coordination sagas. One is like choreography and the other is orchestration. So without going into too deep, because this talk is more like scratching the surface, we're exploring this aspect. But I wanted to point out, so if you have not gotten into it, you may want to also start doing some research on it. One type is called choreography sagas. So as you can imagine too, then what it is that it leverage on an event-driven kind of way of notifying, right? If we're talking about sagas in here, is like there are different components. Say, for example, e-commerce. I think it's a very good example of an e-commerce shopping cart example, right? So a shopping cart, you have somebody that's kind of, it's like a dance ballet, right? Somebody choreograph all the music and all that. So you make sure all the flow is smooth, between the different scenes. And so likewise, right? You can have an e-commerce systems. You have order, kind of order management part. Then you have the payment part, right? And then you have like shipment, for example. Well, these are kind of broad categories of an e-commerce system. So you have somebody who's there, who is kind of like a sort of, think of it more like a coordinator. And so if, actually I should say that one, you don't need a coordinator for the choreographer, but you have a built-in way of triggering if, some order, the steps in your ordering, gets done. Let's say somebody places an order, then it triggers, is event-driven. So an event will kind of be sent out to the payment part, let's say. Now I'm just kind of like broadly kind of using this example, but in reality, it could be more complicated too. But let's say a customer places an order on the web, then you immediately too, then it triggers an event that would tell that, well, order placed. So order placed will then is an event that would actually notify, right? Essentially, whoever is listening to it, let's say is the payment kind of receiver of it. So I received this order entry is placed. So now here I am. I'm going to then check the payment part. But of course, too, before you actually do the payment, you do need to check the payment method, right? What type of method it is. Let's say if it's credit card, then you do need to make sure that the credit card information is being given correctly by the customer. Things like that. So all these small steps too, as you can see, it kind of coordinated well in that sense, being choreographed, but through the use of event-driven way of doing things. And then there's another kind of sagas, which is orchestration. So orchestration, then over there, then you do need sort of like a middleman, kind of a coordinator to coordinate. So it's sort of like, okay, well, you need something done, then it's sort of a broker that tells, all these components, what's going on. These are kind of like the two primary ways of how sagas deal with like coordinating the different pieces of your system that are composed of different microservices to do things at the right time, at the right, essentially. So now then move on a bit to long running action. I'd like to point that out too, is because now I'm working with Open Liberty now. Open Liberty has a very good integration and supports MicroProfile. It leverages on a lot of the MicroProfile, which is an Eclipse Foundation open source project. And as you know, it's really good for building microservices. MicroProfile also has LRA, if you've heard of that, it's long-running action, and it's essentially, leverage on a compensator model. So now, when it gets into compensator, that's what Saga essentially does too. So you may wonder, right? We don't live every day sunny days. Some days are rainy days. In fact, sometimes we get more rainy days than sunny days, which means if there's a failure, then what do, right? We don't roll back. There's no such concept of rollback like a traditional database. This would be what it uses is a compensator. It's essentially kind of look at what didn't go right and basically then go back to reconstructing the state of where your data was, before this failure of this thing. So in some ways, it's not really rollback, right? You just kind of go back in time and kind of reinstate that particular state. like that. So that's kind of like a compensator model in a very high level sense. Of course, there's a lot more details that's kind of involved with this LRA. And example library implementing LRA again is microprofile LRA. So I have links towards the end that if you want to look into that, you're welcome to. And it's a relatively new feature that just got released not too long ago. So even like for us too, we are also trying to come up with examples and to show like how we can make use of it. But there's also a nice blog article that I suggest you to also read that if you're interested. Okay, now then it is a bit of a demo time. And as such too, right, these examples are not like production level yet. All of these are new and, running in a cloud native way. So I have to also say that they may be a bit, not as kind of detailed as you would just take it and go and run and build upon. But certainly there are concepts that we want to illustrate there that you can certainly take and then plug it into your particular application. The first one is a stateful Open Liberty application in Kubernetes. So if you want to follow along, you're welcome to go to this GitHub repository and you're welcome to take a look. Well, actually, you know what? I think I pressed the wrong thing. I'm sorry. I should kind of tell you to go here first because I wanted to actually first get into persistence, session persistence. I wanted to show you first and using Jcache and Hazelcast. So this is actually an example that's taken from the Open Liberty guide. And I also have a link to now. As such, Open Liberty is all open source and we have a very nice team that I, just joining the team, I'm so impressed. We actually have a group of folks and not many of them, just a few and some students too helping us out building the guide. So please, if you want to follow that and along, and let me then also get to my now, we probably don't have as much time for me to actually do very deep dive, but like I said, the code is here, so you're welcome to take it and examine. So this is the GitHub. So just go to maryg-lab, and that's actually a repository that I use for my weekly Twitch session where I do a lot of demo code. Anyway, so I have actually forked this over here in this guide-session. So if you want to take a look, go there. But like I said, I just want to kind of quickly step through and kind of show it to you. It's actually, this guide, right, is pretty good too. What I should show you is here. This is, I also provide you with a link to in my slides. It will be available to you from the conference too. So you can look that up. And the Eclipse Microprofile LRA, this is the draft. And as you can see, this is kind of a newer, just about a year old, this draft. So we have teams that are working on it. So you're welcome to take a look into it. But in the meantime, let me kind of search for my, okay, ooh. I'm so sorry. Here we go. Okay, so sagas too. I also give you a link to, as you know, microservices.io. Chris Richardson is the authority on this topic, right? And then Saga, if you want to read up more on that. Okay, this is the stateful cube demo. So that's the next one that we will have. It's kind of extend upon the first demo. So let me kind of go over here. Okay, if you go to my thing and I have a Java. So this is my maryg-lab. And then if you go to guides sessions, and by the way, if you want to join my project, by all means, let me know too. Or come and join my Twitch streams on Wednesday. I will be talking about that. So over here too, this is the guide session. But like I said, I probably won't actually step through all of it today, but you're welcome to take a look into it, but it will explain too, what is a session. So essentially the state that we're working with right here is making use of the Jcache. As you know, Jcache is a Java spec, right? It's based on the Java spec for Java caching. So it's essentially too, we're illustrating Open Liberty supporting HTTP session data and then using Jcache. And also we're leveraging on Hazelcast in this case too. So you're welcome to kind of take a look, and you're welcome to either you can over here you can, you know what I'll do, so openliberty.io/guides is where you can find a list of all of the guides. Now if you go to the persistence here, and this is where I've cloned from, is this caching HTTP session data using Jcache and Hazelcast. this actually is very good. If you want to follow along, you can clone it into your your GitHub and work with it, or you can follow along and use the guide, because I think the guide is kind of nice too. What you will notice is that with our guide here, we have a version that's it's actually, when you clone it, you'll notice two directories. One is a start directory and one is a finish. Finish essentially contains the finished product, the solution for this exercise. But if you want to try it out yourself, please, we encourage everybody to try out at your own pace, at your own time, right? So it's actually quite nice too. So we encourage you to also use this. And so we'll explain to you what is session persistence. But I just wanted to take the time to kind of explain a bit too, is that, these are how distributed cache is being handled in here. How do you use OpenLiberty's session cache to persist HTTP sessions, right? And then it's basically leveraging on JCache, the standard caching API for Java. So this would be, I think, is a good way for you to start. And then after you set this up, then essentially too, then you can deploy the application to a local Kubernetes cluster. You can kind of set up your Kubernetes if you have one, on the cloud too. You can do that. But the example here makes use of a local Kubernetes cluster, and you can kind of leverage on your Docker desktop too. And it will explain all the steps of how you actually, over here, first of all, right? And you will need Docker. And if you kind of take a look in this whole list of all the steps too, right? It helps you create the application. It's also not too complicated, because we want to illustrate the whole process from end to end. So then how do you run it? And in OpenLiberty too, now there are other exercises you can also follow along in the guides to get used to how do you create a RESTful application, how do you consume it, and how do you actually invoke it, right? We use Maven in these examples, and you can just run liberty :dev. And I wanted to point out too, dev is a very nice feature, because it essentially allows you to do hot deploy. If you have any configuration changes, you don't need to actually shut down your server. You can just simply continue your merry way. You make changes to your configuration, it will read it, hot deploy, and life will be good, after a couple of seconds, right, or something. So that's that. You can kind of take a look too over here too, right? We have a standard cart application. Again, it's a simple case, right? And the server.xml will list out, all of the specific server information, your connection to the Hazelcast library. It will download it for you if you haven't already got it, right? It will download for you every time you try to do a Maven running it, right? All of these things are all here, and it's all set up for you to look at. It's not way too much, so then it's easily digestible for you, especially if you're the first time doing it. And then you can then run it, and then it will show you the list of endpoints. And since I already have it too, I can kind of quickly run it to show you. But over here too, we also provide you with a Hazelcast, the configuration to set up the default cart cluster in here. And then over here too, maybe we won't get into all the details, but please take your time to try this out. We'll give you example of doing Docker pull. You do need to pull your OpenLiberty into your local Docker, right? And then after that, then you do a build, essentially set up your images, right? And then you can then take a look. Then after you set them up, cart app and OpenLiberty, then you can run. Now, our talk isn't about the mechanics of how do you run it, so I won't step. Otherwise this session will go for way too long for you. All of these are pretty standard Kubernetes. You can use kubectl to apply your Kubernetes YAML. The YAML file is set up for you already. It is pointing to the cart deployment, and also the deployment part, and also what service it is, and all that stuff. So you can follow this. It's pretty good. Now, one caveat is that if you have multiple Kubernetes and you're using your control, as you may know, then you want to make sure that your kubectl configuration is pointing to the correct. Let's say if you're running Docker desktop, then you want to make sure that it is configured for that. Otherwise too, if you try to just run it, then it will say you can't run. But like I said, there are some small steps like this kind of have some assumptions that you need to be aware of. But let's get back to a little more. We wanted to take a look into the cart application. The cart application too, essentially too, right? Just a typical simplest case of doing a shopping cart. Your cart application extends the application. We make use of the annotation application application path. And basically let me see, and prepare, where is it? Creating the application. I think, okay, here we go. And card application, we also then would make use of resource, right? The hypermedia kind of resource, RESTful endpoints in here. So over here too, as you can see, we have implementing add to cart. You can take a look at all of these, takes the parameters, item is a string. So essentially too, the path that you can see will have a cart and then slash the item and separated by an ampersand and a price. And that's what will tell, this is the command to add items to the cart is what it is. And so then, all of these you add to cart. And then you can then get cart to see what's in the cart too. So that's what it is. So, okay, how about this? We do a quick run of this, right? And then we can kind of take a look. And let's go back to here. So I have imported this example into my IDE, right? So in this case, I'm using IntelliJ. You can actually do a build. Like I said, I've already set things up. So you should be able to, without changing anything in the finished directory, you should be able to then run it from there too, without changing. But of course, if you want to set up different JDKs and runtime, you can still kind of tweak your particular environment. But if you don't, it should run too. Okay, so that's that. And I think, okay, let's do this one thing. If we follow the example over there, right? And over here. Okay, and oops. It's essentially too, if you see running the application is where we should run. So that's all we need to do is mvn liberty :dev. Okay, so now I'm already here, right? And okay, I want to also do this one thing. In my case, Java. I'm using, by the way, OpenJ9 runtime for the JVM and 15, adopt OpenJDK 15. And you can, of course, download 16 at this point now, time of this, right? And so, and I set up my path correctly. I'm also on the root directory of the guide sessions. Then you should be able to say mvn liberty liberty dev. So this would do the hot deploy one. So now I did actually, when I was testing it, I did run into some issues. So if you run into issues, you don't need to yeah, see, that's what is happening. I think there is some interesting thing, but don't take this as a problem, because it could be my environment. So if you say liberty run, that should also run too. So now once it run, I just wanted to show up to the point in which you can bring up the oh, I'm so sorry, what is going on? Okay, well, okay, and see, there are always something, right? That's kind of like surprising. Now, scanning for problems. Okay, you know what we'll do? If you run into problems like that, what I've done is that I bring up my shell and run things from my shell. Anytime things don't work, bring up your command line. So that should always work. So, okay, so here we go. As you can see, I've already done some testing, right? That's actually late at night when I was doing it. So, okay, so let's do that. Oh, you know why? Because I wasn't in the correct directory. I should be in the finished directory. Okay, let me clear it. And okay, so I'm in the finished directory, and that's where the project is. So I can actually do liberty. Oh, okay, let me kind of make sure too. We have path set correctly, yes. And then it's good because it's showing my adopt OpenJ9 is 15. Okay, so now let's do that. Okay. So like I said, right, sometimes if IDE doesn't work, go to command line. It's supposed to work. So okay, so now this is going to take a bit of time, but I want to show you up to the point in which the app startup, and then you'll be able to actually input your cart data into that. I think it should be fun to at least show this part for today's talk, right? And so, okay, let's see. Now, if this is up, then you should also see a message for Open Liberty. It says, you're ready to build a better planet, something like that. So it's pretty cool. So let's kind of take a look. Ooh, something else. All illegal reflective access operation, something. Ooh, okay, well, over here. Actually, I'm good. So the default server, as you can see, The default server is ready to run a smarter planet. Then my server is up. Okay, so in order to run it, you just run localhost 9080 open API /UI. Okay, ta-da! So now you have the application. So now this, I think it is pretty cool. Then you can then play around with it. And like I said, right, the application isn't like very, very complicated that, would take you too long to kind of get used to. I think it's a good way, for you to kind of get your feet wet into this. And then you can build really serious applications after that. So, okay, so let's take a look, right? We can do a post. This one was essentially, we'll add a new item to cart, right? So let's do that. And try it out. So you press try it out. And then over here, you add the item. Let's say we want, what should we get? Let's get bananas. I don't know why, because I think I just had a banana right before this. So I think of bananas. But let's say bananas, and the price, let's say, okay, $2. Takes a number. So let's say 2. Okay. So after this, execute. Okay, so it's set as successfully added to cart. Okay, now, okay, that's what it says, right? And you see the response header does come back, and it also says bananas added to your cart costs $2. And now let's do a get. So get doesn't take any parameters. We just say try it out, and it should then can't execute. Yay! I think we're good, right? Are we? Yep, we're good. So response body will now show that we have our cart data, we have bananas, and then the separator that says $2. So subtotal is 2. So that is correct. So please take a look and then let me know what you think of it, right? So okay, I think I've been talking a long time, but like I said, right, let me get back to my slides at this point. And so over here now, that's what we play with just now is, the Open Liberty session persistence using JCache. But let's also then now look in, just give you the, oops, somehow I think I lost track of this. Okay, here we go. Demo. And this is the stateful cube demo that I was going to say is basically Open Liberty application. And this one will actually be making use of Nginx and the Hazelcast and build upon that. And we'll can illustrate to you too running this in a true like Kubernetes environment. So this one, I think we do not have time to go over it today, but I encourage all of you to visit that, and you should be able to follow the examples too. It has all the readmes in there. You should be able to handle that. Yeah, it is good. So, but feel free to contact me, follow me on my Discord, and talk to me about what you think of it too. Okay, so here we are. I think I've already talked enough time. So let me give you a list of resources and links. And like I said, this is only the tip of the iceberg. Please do look for me for any future talk. I do intend to do more talks in this area now. Now I'm like all excited, wanting to get more into, say, the saga patterns, things like that. If you're interested, I love to have more conversations with that. Okay, here we go. Resources. So these are a bunch of like code examples, design patterns, and open source libraries that I've touched upon. So these two are the GitHub link to the two examples, one of which we worked on, the other I just pointed out to you. Please take a look. It's developed by our offering manager, Graham Charters. And so he was like gladly sharing with me. I said, okay, let me share with the audience about this Open Liberty application in Kubernetes. And so now there is also Saga design pattern. Please take a look. That's from Chris Richardson's website, microservices.io, and Microprofile LRA. So please visit that. And also a very nice blog written by one of our engineers, Jason. He wrote that. It's a very nice blog too that was published back in January. And these are links to our Open Liberty project, Microprofile, and also Jakarta EE. Then the next thing is a bunch of all the links to developer.ibm.com. We have a lot of resources for not just microservices, but for other things like the cloud, DevOps, cloud native, you name it. We got everything that you need. And programming with Java on IBM Cloud too has got some nice materials there. Okay, then outside of us, we have the CNCF, Cloud Native Computing Foundation, the 12-vector app. And so please take a look. And then if you want to get hands-on experience with a public cloud, we have our IBM Cloud sign up. And this, we have like about 40 free things that you can use in there. There's no time limit to the free things that you can try out. And no credit card is required. We won't go after you. We won't terminate your account even if there's actually no time limit for the free tier. But of course, then there are things that you do need to pay for if you want to get more serious too. But we can talk about it. If you are a startup company, we actually have very nice support for startup companies if you qualify, right? So talk to us too, and we'll get that set up for you. And join our expert TV and meetups, right? And these are free training on many topics. I really highly recommend too. Also the IBM developer San Francisco Bay Area or the New York City one. Well, even like in Germany, in Middle East, if you're there, everywhere too, all of the IBM developers have really great materials. And also myself, Chicago Java Users Group, if you want to join us, we have like on average 1 to 2 meetups on many different topics too. Okay, and then please consider joining us there. Lots of resource. And this is for IBM. We have a call for code, giant worldwide hackathon, big top prize winner, 200,000 US dollar for top prize. So visit callforcode.org. And then I mentioned about my Twitch stream. IBM Developer live stream on Twitch. So if you want to visit that, is twitch.tv IBM Developer. I actually run that every Wednesday at about 1 o'clock. Sometimes I may skip, but I like to encourage you to also join my Discord server, because over there I'll communicate to you if I'm late, if I have to skip or change time and all those things. And then we have other developer advocates also presenting many other topics too. For example, JJ is on DevOps and Upcar is doing call for code. So all of these wonderful folks. And with that comes to a close, and thank you so much for having sat through my presentation. I hope you're finding it useful. I may be kind of new to this area myself, so I'm learning and I'm finding answers out. I want to find answers out for you to make your job easier. And so is all of us at IBM as well. Please consider joining me on Discord if you want to scan that or get this code, discord.gg. If you don't get it, don't worry about it. Just follow me on Twitter too, or find me on LinkedIn or GitHub or dev.to. And I promise that I will beef up all my blogs too. So everybody, thank you so much. And I hope to see you in person at a conference, at some point very soon. And I also pray special prayers for those who are still affected heavily by the pandemic. And thank you. And you all take care.